Hello. This is going to be a short tutorial on the use of the Extrude and the Revolve tools. We'll go into some detail about each of those tools' individual menus, what each option does, and we will demonstrate some of the workflow things to keep in mind while using those tools. So, with that being said, let's get started. As always, I'm going to create a new component since this is the start of a new file. And we'll call this component part 1, or 1. There we are. And the first tool I'm going to demonstrate is the use of the Extrude tool. So I'm going to begin a new sketch. I'm going to start on the XY plane in this circumstance. I'm going to create a square, and I'm going to add some dimensions to it. This square is fully defined, and the most simple utilization of the extrusion tool is to simply at this point, once you have a enclosed, fully constrained profile, finish your sketch, activate your extrusion tool in the top left here, and we can begin looking at the options we have available to us inside of the extrusion menu. We have two up at the top. We have a regular extrude, and then we have a thin extrude. A regular extrude will create a solid body, and a thin extrude will create effectively a hollow body. So if we, as an example here, if we go to our regular extrusion and we have, we say 100 millimeters. Okay, sorry about that. Ran into a technical glitch. So let's draw that square again. And let's 50 by 50. E for extrude. And we'll do a solid extrusion. We are going to select our profile, and we're actually going to change the direction. And we could pull it out this way, or we could extend it in this way here. The other options that we have available to us are the two-sided. So this allows us to extrude in two directions, but control their extrusion lengths independently, like so. And the third option we have here is symmetric, which will extrude the same amount in both directions simultaneously. These can be used situationally for different in different contexts. Choosing a symmetric extrusion method can be very beneficial when you're attempting to model certain types of geometry. I'm not going to need to go into detail about all of those particular cases, but as a general rule, if you intend to make a symmetric piece of a symmetric solid body in some fashion, choosing the symmetric extrusion method can be beneficial because it can allow you to take advantage of one of the base planes of the modeling space. So the XY plane or the XZ plane or the YZ plane. And you can then use that plane as a reference for creating other symmetrical features on your part. For now, though, I'm going to simply just use a one-sided extrusion, and we're going to click Enter. And we now have our box. When we are using, and when we're creating, using the extrusion tools, and in general, when we're creating three-dimensional geometry, we want to make sure 95% of the time probably actually closer to 99% of the time, we want to work from our least complex and most primitive shapes to our most complex and most to our most complex shapes and our most detailed shapes. So we start as simple as possible, and then we move towards complexity as we go through the modeling process. And adding too much complexity too early in the modeling process can set us up for failure and can also introduce a lot more difficulty and troubleshooting that has to be done with the model um, later in the process. So, best practice is KISS, keep it simple, and always start simple and then move towards more complexity. So in this case, if we were to, if we wanted to add some additional smaller features to this, now would be a good time to begin doing that. And so I'm going to demonstrate another aspect of the extrusion tool that we can actually we can create or we can cut away material from an existing piece of solid geometry. So I will grab the rectangle tool again, just for the sake of simplicity. I'm going to say, I'm going to set up some constraints here. And we will say that there we are. There we go. That's there. And now we're going to, with this sketch finished, we're going to hit the E key for our shortcut to activate the extrusion tool. And then we're just going to click with those two profiles selected on the opposing side. And you will notice that when I hit enter, the material described by those two profiles I made has been cut away. And this is one of the basic ways that we can begin to create more complex geometry. And we can do this with basically any enclosed profile of a sketch. Keeping in mind that it is always best practice to fully constrain a sketch, except with a few exceptions that we'll probably get into in about 2 weeks. We really prefer to create three-dimensional geometry from fully constrained sketches. But there are no limitations really to the shape of those sketches in terms of performing extrusions. So, as an example, I'm going to use our line tool, and I'm going to create a very oddly shaped profile. And we're going to spend some time fully defining this, because if I'm saying it's best practice, I should, I feel, definitely follow my own advice. So in this particular case, I'm being fairly fast and loose with the dimensions that I am creating, because the shape here is non-critical, and I'm simply doing this to demonstrate a point. Okay, so we have fully defined this very odd, very messy looking shape. Forgive the poor dimensioning practices. So now that we have this shape, we can, since it's a fully enclosed profile, simply extrude cut it like so to create that shape, or we could extrude it as a solid body. Both of these are valid ways to create geometry in Fusion 360. From there, we could continue to sketch. Uh, we could continue to add features to this block, but I'm going to begin moving into doing some more um, demonstrating some other functionality of the extrusion tool. So we are going to actually start a brand new file. I'm going to close this other one, and I'm not going to save in this circumstance. But we are starting a new file, so we're going to create a new component. I'm going to call this part 2. And we will begin sketching on the XY plane again. And we are going to be using our rectangle tool. And now I am going to, and now that we have this rectangle here, I'm going to demonstrate another feature of the extrusion tool. If we come into this menu down here and we look here at the at this option here down at the bottom, taper angle, we can create an angle to the extrusion that it corresponds to what would normally be the vertical sides of this box. So if I pull straight up, you can see that in profile we're creating something that's roughly funnel or cone shaped, or a funnel would be a better term here. If we move in the, and that's in the positive extrusion direction. If we move in the negative extrusion direction, from the same orientation of the camera, we start creating something that is more pyramid-like. And we can also see that if I rotate in the opposite direction, you can see that we have this taper here. And we can make this taper more acute. Since I accidentally entered that value, now would be a good time to demonstrate one of the features of the timeline. Any operation that you create or that you complete in Fusion 360, for the most part, will show up as an event in the timeline. This allows us to go back at any time and edit any feature that we've created. To do that, you simply come down, mouse over the feature you want to edit, and right-click, and then we are given two options. Since this is solid geometry or three-dimensional geometry, we can either edit the command that created that three-dimensional geometry, or we could edit the associated sketch profile that the geometry was created from. In this case, we're going to edit the feature, and now I bring back the extrusion menu with all of the settings that I had entered previously. And now I can edit them as I please. So if we did 50, we see something like that. If we enter 0, it will just be completely vertical sides. If we enter a negative value, you can see the impact on the shape that had. If we do, and you can even add decimal values here if you would like. You can also, in preferences, change whether or not this is degrees or radians. That's located in the preference menu, and we'll talk about editing the base preferences for Fusion in a separate tutorial. So in this circumstance, I'm going to say 10 degrees. I'm going to click OK. And now now that we have this shape, I'm going to demonstrate a tool that is very commonly used with the extrusion tool, and that is, it's one of our first tools that we use to modify components, and that is the shell tool. If we click on the shell tool, any object that we click with it, we select an object that we wish to shell, and then if we are asked to provide an inside thickness. And in this case, let's say 2.5 millimeters. And we will click OK. Now, the object does not appear to have changed. However, if we were to now extrude backwards, let's keep going. There we go. You can see that this part is actually hollow. The combination of extrude and shell can be a very quick way to create parts that would otherwise take a decent amount of time to sketch the profile accurately in 2 dimensions. So moving back and forth between a sketched profile and using tools to modify existing geometry, there's a little bit of a kind of tug of war as you gain experience in CAD about which methods you like to use under what circumstances. Again, a lot of learning the nuances about when it would be beneficial to choose one method over another at this stage just requires reps in the software and practice modeling all kinds of things. So as we encounter these problems and as you encounter issues, Nate and myself will be there to assist in figuring out what is the best approach at these particular times. So again, we encourage you to come into the lab if you're having problems and find us and we can help you. So that is this is one method to get a thin-walled part. The other method that we could use would be to create a thin extrusion. And so I will demonstrate that now. I'm going to back up a few steps here. And then we're going to come back and we're going to hit Edit Feature. We're going to select Thin Extrude. We have our taper angle, and then we're going to select our wall thickness. And here we could say 2 millimeters, that's fine, and click OK. Give my computer here a moment to, and there we are. Looks like I have a little bit of a graphical glitch right now. I might restart here in a moment to get rid of that. But here is, this is the effect of the thin extrude option. You'll notice that the tops and bottom of this component have disappeared. And so that's one thing to keep in mind versus thin extrude or the shell operation. The shell operation will allow you to keep the object fully enclosed, or to selectively keep or remove faces of the object. We'll get into that in another tutorial when we go more in depth into the shell tool. So for the basic operations of the extrusion tool, that's the basic functionality. And so you can create tapers, you can use the extrude tool to create geometry or to remove geometry, and you can also use the extrude tool to create thin-walled features or solid body features. Okay, let's move on to the Revolve tool. I am going to start another part. We are going to create a new component since this is a new design. Call this part 3. And we will, again, sketch on the XY plane. Now, with the Revolve tool, I'm going to demonstrate a few different things you can do with the Revolve tool, but the workflow for the Revolve tool is a little bit simpler overall. First thing I'm going to do is I'm going to offset my start point from the origin, and I'm going to create this profile here. And I'm just going to add some dimensions. For this profile. And then I'm going to bring our line tool back, and I am going to create 2 pieces of construction geometry because I want to demonstrate how the Revolve tool will behave depending on which axis you select as your point of reference. And so we will, there we go. For some reason I'm struggling with the line tool. There we go. So now we're going to finish this sketch and we are going to select the Revolve tool. When I selected the Revolve tool, it automatically selected the only enclosed body or only enclosed profile, excuse me, that was available in the sketch. If you have multiple enclosed profiles in the sketch that are not connected to each other, Fusion will require that you select one. As a general rule, if you're using the Revolve tool, it is best practice to to segregate individual solid bodies for the model into their own sketches. Okay, so we have this profile selected. Now we are asked to provide an axis. And this axis is the axis that we will rotate around to create the model or to create the geometry. So if I select this axis, you can see from the preview that we create this dish shape. And if we look at this in profile, you can see that what's happened is that this profile has been spun 360 degrees around this axis here. If I deselect this axis and I instead select this axis, you can see that the shape that we get dramatically changes. And we now have something that looks much more reminiscent of a screw or some type of pin. And the profiles that you can revolve can be very complex. To demonstrate that, we will back up a moment here, and I will create a new profile. Again, forgive the messy dimensioning. This is simply for expediency's sake, so I can demonstrate that the profiles that we can generate with the Revolve tool can be very complex. And so you can see here that we have a curved surface on the interior, and then we have 3 different types of geometry on the exterior. And so if you're in a situation where you need to make grooves in circular parts for that have like lots of O-ring or gasket seals, snap rings, etc., um, the Revolve tool can greatly simplify and increase the speed of your modeling by using the ability of the Revolve tool to create a profile and then create circular geometry with that profile. So something to keep in mind. I'm not going to go into, I think, any more detail on the Revolve and the extrusion tools in this tutorial. Um, if there is an edge case that one of you runs into, please find myself or Nate, and we will be able to help you inside of the context that you're working. So, as always, we look forward to seeing you guys in class. Have a great day.